Hello friends, in this video today we are going to discuss this topic of ray optics, refraction at spherical surface. Okay, and also we are going to prove this relation, and this was asked in ACE's final examination 2025 under Assam Higher Secondary Education Council. So before we start, please do subscribe to the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you want to follow me on Insta, you can follow me on Insta. This is my Insta ID, OJHALAKHYAJIT123. This is my Insta ID. You can follow me on Insta. Okay, and please do subscribe to the channel. So now let's start our topic. So here is the question that was asked in 2025 ACE's final examination. Okay, first let me show you the handwritten notes on this topic, then I will explain this topic. Okay, here is the first page. Okay, take the screenshot or you can pause the video and note it, and let me go to the next page. This is the next page. Okay, first take the screenshot of this handwritten notes, and then I'm gonna explain each and everything. Okay, so now next page is this is the last page. Okay, now let me explain. So here you see, here we have a spherical surface, and this is the denser medium. Okay, of reflective index n1, n2, and here is the rare medium. Okay, for us. Reflective index is suppose n1. Okay, so suppose here on this axis, principal axis, there is an object that is suppose O is represented by O. Okay, so here is the incident ray on this spherical surface. Okay, and this point is P, and here is the center of curvature C, suppose. Okay, center of curvature C, and the image is formed at this point, suppose I. This is the point where the image is formed. Okay, so now you see, this is the refracted ray. Okay, where we have got the image. This angle is suppose beta. Let me take this as beta. Okay, this angle is beta, and so you know how to draw the normal at this point. Okay, that normal should be passing through the center of curvature, right? So here is the normal. Let me use another ink. So this is the normal. Just let me draw it properly. Okay, here is the normal at this point, right? So this is the angle of incidence I. Okay, and this is the angle of refraction R, and this angle is suppose gamma. Okay, and this angle is suppose alpha, right? Hope you have understood this. So now, okay, let me give the direction properly. Okay, this arrow represents the direction. Okay, so now you see, so let's draw a perpendicular from this point to the principal axis. So here is the perpendicular, suppose. Just give me a second. This is the perpendicular. Okay, so this is 90-degree perpendicular, and this point is suppose N. Okay, now object distance is represented by U. This is the object distance. Okay, and the radius of curvature is represented by R, right? And image distance, here is the image distance B. This is the image distance B, right? So hope you have understood these things. Okay, so the aperture of the assumed to be very small. Okay, so that this n point is very close to P. Suppose you have taken two curved surfaces, this one and this one. Here you see, so there is clear difference between the aperture of these two surfaces. So here you can see this is the principal axis in both cases. If you suppose, let me draw a level from the point on same level from these two glasses, surfaces. If you draw perpendicular here and if you draw a perpendicular from here you see, in this case this point is closer to this point compared to these 2 points. Okay, here you can see these 2 points are closer compared to these two, right? Because here the aperture is small. Okay, so hope you have understood what I am trying to say. So that's why here this perpendicular distance, if these 2 points are very close, P and N are very close, let me take this point is suppose M, where the incident ray strikes the surface. Okay, so if these 2 points are very close, we can consider that MP and MN are equal, right? This MP and MN are equal. We can consider approximately equal. MP approximately equal to MN, right? So hope you have understood this. Since this is denser medium, so the refractive index of the denser medium, that must be greater than the rarer medium, N1. Okay, so now you see what I am going to do here. Now let us take this triangle OMC, this triangle OMC from this triangle, right? Hope you can see it clearly. OMC, this is OMC. Okay, so now you see from this triangle, let me draw here. This is like this, OMC. Here is the gamma and this is alpha, and this angle is I, angle of incidence. We know that the exterior angle of a triangle is equal to the sum of the two remote interior angles or opposite interior angles. So from this triangle OMC, from triangle OMC, we can write that I is equal to alpha plus gamma, right? Similarly, from this triangle, you can see from this triangle MCI, this triangle. Okay, from this triangle, what we can say, this triangle, hope you can recognize it in the diagram. Just follow the points. Okay, MCI, this is MCI, right? So here this angle is beta, right? This angle is beta, this angle is gamma, and this angle is angle of refraction, this one R. So this is exterior angle, so it must be equal to the sum of this and this, right? So therefore we can write, just let me clean this, that from triangle MCI we can write gamma is equal to R plus beta, right? So let me take both this equation as equation number 1, right? So hope you have understood this. Now according to Snell's law, okay, according to Snell's law, you see this is here you see this is the incident ray and this is the refracted ray, right? And this is refractive index or refractive index of this medium is N1, from which medium the refractive index is incident ray is going to strike the curved surface, spherical surface, and after refraction it travels through the medium, denser medium of refractive index N2. So Snell's law says that N1 sine I is equal to n2 sine r. Now you see, so you see, though I have drawn this incident ray like this, I have let me assume that incident ray strikes the surface. I have considered here you see there is not a single ray of light will strike this surface. Okay, there will be large number of rays. Okay, so I have considered a ray that strikes at the spherical surface at a point which is very close to this point P. Okay, which is very close to this point P. For that kind of ray, this angle alpha will be very small, right? And similarly these two angles will be also very small, right? So let me assume that this ray, incident ray that I have drawn here, though I have drawn like this with a bigger angle, let me consider that this incident ray strikes this point M is very close to P. Okay, let me assume that way. Okay, so in that case we can write sine I is approximately equal to I and sine R is approximately equal to R. Okay, so that's why in that case this relation will be n1I and n2R, right? That's what we're gonna have. Now let us use these two values of I and R. Okay, from here we can find R is equal to gamma minus beta from this one, and let us put I here and here. Okay, so if we do so, then what we're gonna have n1 alpha plus gamma, on the other side n2 R is equal to gamma minus beta. So using equation number one, right? Now let me copy this last step and let me go to a new slide. So here is the last step I have got, and if we simplify this, then what we're gonna get, n1 alpha plus n2 beta is equal to n2 minus n1 gamma. So how I have got this? First let me open these two brackets, expand these two, then what we're gonna get, n1 alpha plus n1 gamma, on the other side n2 gamma minus n2 beta. So what I have done here, I have brought this down to this side, left side. So we have got this side and this one is transferred to other side, so then we have taken this gamma common to obtain this term, right? So hope you have understood this. So that's very simple. This is equation number, suppose 3. So where I have given equation number 2, so here it is suppose 2. Okay, Snell's law. So this is 3. Now let me go back to the diagram again. So here is the diagram. So you see, from this triangle MON, from this triangle MON, this triangle, here it is alpha, right? So hope you can recognize it, MO and this triangle. From this triangle, this is angle alpha. What we're gonna get from triangle MON, we will get tan alpha is equal to perpendicular, that is MN, by base, that is ON. That's what we're gonna have. Okay, so let me copy this and let me go to the new slide. From triangle, what was the triangle? MON. Okay, from triangle MON, what we have got tan alpha is equal to this. Similarly, let me write it properly, MN by ON. Okay, similarly from triangle MCN, so here you see this triangle MCN, this triangle. Now take this triangle. Okay, so let me clean it first, just wait. Now consider this triangle only. From this triangle, what you're gonna get? You're gonna get tan gamma is equal to perpendicular, that is MN, divided by base, that is Cn, right? Mn by Cn. Now let me copy this and let me go to a new slide. Which triangle we have taken? M and C. So from M and C, from triangle M and C, what we have got? We have got tan gamma is equal to this. Now similarly, let us take MIN, this triangle. Now let me clean this. Just give me a second. Just wait. So now this triangle MIN. Okay, let us take this triangle MIN. Okay, these 3 points, connecting these 3 points. Okay, the triangle form is MIN. So here it is beta. From this triangle, let us find tan beta. So here perpendicular is again MN, and the base is in this time this is NI. Now let me copy this and let me go to the new slide. So which triangle we have taken? MIN. Okay, so let me write from triangle MIN. So what we have got? We have got tan beta. So we have got these 3 relations. So as I have already mentioned earlier that alpha, beta, gamma, these angles are very small. So we can write that tan alpha is approximately equal to alpha. Similarly, tan beta is equal to approximately equal to beta, and tan gamma is approximately equal to gamma, right? So this can be replaced by gamma, this can be replaced by alpha, and this can be replaced by beta. If we do so, then what we're gonna get? Alpha is equal to Mn by On, right? Alpha is equal to, we're gonna have Mn by On, and gamma will be equal to Mn by Cn. Right? And beta will be equal to Mn by Ni. That's what we have got, right? So hope you have understood this. Now using this result in equation number 3. Okay, so let's put the value of alpha, beta, gamma here. Okay, let me use this result. Using this results, in equation number 3. So if we use those result in 3, if we replace this gamma by this alpha by this, then beta by this result, and gamma by this result, then this relation will be like this. Then what we will have? Then we will have N1 Mn by On plus N2 Mn by Ni, okay, is equal to N2 minus N1 into, now gamma is replaced by Mn by Cn, right? Mn by Cn. So here Mn by Cn, that's what we have got. Okay, now let me copy this and let me go to a new slide. Okay, so here is the last relation that we have got. Let me rearrange it. Okay, so here is the relation. So now you see, let me draw the diagram again. Let me wait, give me a second. Okay, now let me copy this diagram. Okay, let me draw it in the new slide. Okay, so here is the diagram. Just give me a second. This is the diagram, right? So here you see. Now this you can see that Cn and Cp, these are approximately equal. Okay, Cn is almost equal to Cp, as I have already explained why that P and N are very close, right? Cp, which is approximately equal to R. So we're going to consider this side as positive and this side as negative using the sign convention. And then OP OP is also approximately equal to, you can say, ON, right? OP and ON, since P and N are very close, so that's gonna be, this side is negative, so this side is negative, so here we're gonna write minus U using the sign convention. Then PC, I have already mentioned PC, CP, PC, same thing, and CN. Then let me mention PI. This PI, this length PI from P to I, that is B, okay? So that side is positive, PI. So PI gonna be approximately equal to NI. So this P and N are very close, so again plus B, that's supposed to be B. This is the image distance. So here you can see, you can replace ON, NI and CN by this value, ON by this, CP by this, NI by this, right? CP is equal to CN, right? So CN can be replaced by R. Then NI will be replaced by this B positive, and ON will be replaced by minus U, okay? In that case, we're gonna get this, if we replace those by these values, then we're gonna get N1 by minus U plus N2 by V is equal to N2 minus N1 by R. So let me rearrange this relation, that N2 by V minus N1 by U is equal to N2 minus N1 by R. So this is the required relation, right? So hope you have understood this. So thank you for watching. See you in the next video. Bye bye.